Good morning, everybody. I am Mahima saxena, assistant professor at AKGEC department. Today's my topic is genetic algorithms. Now, what is genetic algorithm? Basically, a genetic algorithm is an adaptive heuristic algorithm derived by Darwin's theory of evolution in nature. It is used to solve optimize problems in machine learning. It is one of the important algorithm to help as it is help to solve complex problems that would be take a lot of calculations and a lot of time to solve. Basically, genetic algorithm is used for solving complex problems like that have lots of data sets, time consuming, and higher in cost. Genetic algorithms are being genetic algorithms are widely used in different real world applications. For example, we have designing electronic circuits, code breaking image and image pre-processing and artificial creativity. Basic terminologies. Population is the subset. Basic term, we have like different terminologies for genetic algorithm like population, chromosomes, genes, alleles, fitness functions, and genetic operators. Now first we will I'll explain all these terminologies. Now first I will explain what is population. Basically, population is the subset of all possible or probable solutions which can solve the given problems. Basically, it's kind of a data set that we have, and we solve the problems with the help of data set. In this data set, we use different types of approaches like sampling. We have different types of sampling like random sampling. Now, random sampling or statistic sampling. In random sampling, we collect the data randomly. But in statistic sampling, we put data in a static format. Like for example, we have a class of students. They have boys and girls. Now I want to pick all the students who's having odd roll numbers. This is called static sampling. Now what is random? In randomly, I put anyone according to me. This is called random sampling. Now the second part is chromosomes. A chromosome is one of the solution in the population for the given problem, and the collection of genes generate a chromosome. This is called a chromosome. Now what is a gene? A gene is divided into a different gene, or it is an element of the chromosomes. Second terminology is LA. LA is the value provided to the gene within a particular chromosome. Now fitness function. The fitness function is calculated. We need to calculate the fitness function. Now what is fitness function? Fitness function is used to determine the individual's fitness level, fitness level in the population. It means the ability of an individual to complete. It means the ability of the individual to compete with the other individual. In every iteration, the individuals are evaluated basically on the basis of their fitness function. Second is genetic operators. In a genetic algorithm, the best individual mate to regenerate the offsprings better than parents. Here, genetic operators played the basic roles in changing the genetic compositions of the next generation. After calculating the fitness of every existed in the population, every existed offspring or population in the offspring, a selection process is used to determine which of the individual in the population will get to reproduce and produce the seeds that will form the coming generations. Now, on the basis of which we select, there are three methods available for selection. The first is roulette wheel selection, second is event selection, and third is rank grounded selection. So now we can define a genetic algorithm as a heuristic search algorithm to solve optimization problem or basically optimization problems It is a subset of evaluationary algorithm which is used in a particularly in a calculating the fitness function, or genetic algorithms use genetic and selection concepts to solve optimization problems. How a genetic algorithm works. The genetic algorithm works on the evolutionary generational cycle to generate high quality solution. These algorithms use difficult operations that either enhance or replace the population to give an improved fit solution. It basically involves 5 phases to solve the complex optimizations problem now which are discussed here. First is initialization, second is fitness assignment, third is selection, fourth is reproduction, and fifth is terminology. Now, first is initialization. Now, what is initialization? The process of a genetic algorithm starts by generating the set of individuals which is called population. Here, each individual is the solution for given system, for a given problem or given system, and individual contains or is characterized by a set of parameters, called genes. Genetic algorithms genes combined into a string and generate the chromosomes which we used in the next process. One of the most popular technique for initialization is the use of binary strings. Next is fitness assignment. Fitness function is used to determine how fit an individual is. It means the ability of an individual to compete with other individuals. In every iterations, the individuals are evaluated based on their fitness function. The fitness function provides a fitness score to an individual. This score further determines the probability of being selected for any reproduction. The higher the fitness score, the more the chances of getting selected for reproduction. Next topic is selection. The selection phase involves the selection of individual for the reproduction of offsprings. All the selected individuals are then arranged in a pair of 2 or to increase reproduction. Then these individuals transfer their genes to the next generation. There are 3 types of selection methods available, which are roulette wheel selection, tournament selection, rank-based selection. Now, what is roulette wheel selection? The roulette wheel selection method is used for selecting all the individuals for the next generation. It is a popular selection method used in genetic algorithms. A roulette wheel is constructed from the relative fitness ratio of individual. Now, what is relative fitness? Basically, relative fitness is a ratio of individual's fitness upon total fitness of every individual, of a particular individual. It is represented in the form of a pie chart where the area occupied by each individual on the roulette wheel is proportionally to its relative fitness. This is called roulette wheel selection method, and it is generally used for selecting all individuals for the next generation. Second method is tournament selection. Now, what is a tournament selection? Tournament selection is a selection strategy used for selecting the fitness candidate from the current generation in a genetic algorithm. These selected candidates are then passed on to the next generation. In a K-way tournament selection, we select K individuals and run a tournament among them. Only the fitted candidate among those selected candidate is chosen and is passed on to the next generation. In this way, the such tournaments take place, and we have our final selection or candidates who moved on to the next generation. It also has a parameter called the selection pressure, which is a probabilistic measure of a candidate likelihood of participation in a tournament. This is called a tournament selection. Next is rank-based selection. The rank-based selection is a hybrid instance selection technique that can be divided into two phases, ranking and selection. During the ranking phase, rank-based instance selection associates a score to each instances in a training set. In that training set, they associate the score with with each instances in the training set. The score represent the importance of each instances for classification purpose. The higher the score, the more the importance of the instance. Now the second is, after the construction of the ranking, the selection phase keeps the instances and keeps going the highest ranking. Third is reproduction. After the selection process, the creation of a child occurs in the reproduction step. In this step, the genetic algorithms use two variations operators that are applied to the parent's population. The two operators involved in the reproduction phase are crossovers. The first is crossover. The crossover plays a most significant role in the reproduction phase of genetic algorithms. In this process, a crossover point is selected at random within the genes. Then, the crossover operators swap genetic informations of two parents from the current generation to a new individual representing the offsprings. The gene of parents are exchanged among themselves until the crossover point is met. These new generated offsprings are added to the population. This process is also called as crossover. Types of crossover styles available: 2-point crossover, library crossover, and inherited algorithm crossover. Now the second is mutation. The mutation operator inserts random genes in the offsprings, basically new child, to maintain the diversity in the population. It can be done by flipping some bits in the chromosomes, and it will called mutation. Mutation helps in solving the issue of parameter convergence and enhances the diversity and enhances the diversification. This basically shows the how to work. Types of mutation styles available: flip mutation, Gaussian mutations, and exchange swap mutations. Next is termination. After the reproduction phase, a stopping criteria is applied as a base for termination. The algorithm terminates the threshold fitness. The threshold fitness solution is reached. After it will identify the final solution as the best solution in the system, in the population. Now, after some time, some threshold is set, and when we find the best solution, when we get the solution, and if it hits the threshold level, then this is the best solution for our algorithm. Advantages of genetic algorithm. The parallel capabilities of a genetic algorithm are the best. It helps in optimizing various problems such as discrete functions, multi-objective problems, continuous function, etc. Now, what is discrete functions? Discrete functions are some classification functions that we have classified in two types, basically in two classes. For example, binary classes, male, female, true, false, yes, no. These are the binary functions, or these are the binary classes. It is not any hard and fast rule that it is always binary. It is ternary also, and many more, etc. Now, what is continuous function? Continuous function is a range, basically, like from 1 to 100. This is called a continuous range. That's it. It provides a solution. Basically, it provides a solution for a problem that improves our time, that improves our efficiency, etc. A genetic algorithm does not need derivative information. Genetic algorithm does not need a derivative information. That is, when we start to apply a genetic algorithm, it does not need any derivative information. Limitations of genetic algorithm. Genetic algorithm are not efficient for solving simple problem. Basically, genetic algorithms are for complex problems that is very time consuming. If we apply genetic algorithm on simple problem or easy problems, it will waste our time, it will waste our money, it will waste everything. Because of that, genetic algorithm only applies on complex problems. It does not guarantee the quality of the final solution to a problem. It never guarantees the quality. Basically, it doesn't guarantee that the solution we get after applying the genetic algorithm is always the best solution. Sometimes it's worst solution. Sometimes the solution is like not according to our needs or not according to our expectations. Repetitive calculation of fitness values may be generated. Some computational challenges also occur. We need to calculate fitness function. If we are applying, suppose we are applying genetic algorithms. In genetic algorithm, the first phase is initialization. After that, it is called the fitness value. We need to calculate the fitness. Calculating fitness is a time consuming process, and we need to calculate fitness repetitive in a repetitive nature. Because of that repetitive nature, it is not good to applying genetic algorithms on simpler problems or on any problem, because it is time consuming. Difference between genetic algorithm and traditional algorithms. A search space is the set of all possible solutions to the problem. In the traditional algorithm, only a set of solution is maintained, whereas in a genetic algorithm, several set of solutions in search space can be used. Okay, now what does this mean? In genetic algorithms, we have set of solutions that are applied by different algorithms. What is a search space? A search space is a space where all the solutions are present. The solutions from different algorithms that are present. But in traditional space, we have only one set of solution that is present or that is maintained. But in genetic algorithm, different sets of solution is present. In traditional algorithm, we need more information in order to perform search, whereas in genetic algorithm, need only one objective function to calculate the fitness of an individual. In traditional algorithm, we need lots of information to perform our algorithm, to perform our search. But in genetic algorithm, we only need one objective function, that is for calculating fitness value for fitness of an individual person. After that, we calculate fitness function, it will replicate all the things. Third is traditional algorithm cannot work parallelly, whereas genetic algorithm can work parallelly. Now, what is the mean to work parallelly? Basically, in genetic algorithm, calculating the fitness of the instances of an individuals are independent. Traditional algorithms cannot work parallelly, but genetic algorithms can work parallelly. They calculated the fitness functions of particular individual are independent. It doesn't depend on any other thing. But in traditional algorithms, some parameters are present that are not independent, that are dependent. Third is, one big difference in genetic algorithms and traditional algorithm is that rather of operating directly on seeker's result, inherited algorithms operate on their representations. On their representations, frequently apparentized to a chromosomes, etc. The biggest challenge is that it doesn't work on operating systems. It works on inherited algorithms. One of the biggest difference between traditional algorithm and generative algorithm is that it does not operate on candidate solution. In starting, I explain what is candidate solution. Candidate solution is basically an algorithm that works on both the approaches, positive examples and negative examples. But in find S algorithm, it only works on negative example. It only works on positive examples. It ignore negative examples. That is saying that the difference between the traditional algorithm and the genetic algorithm is that it does not operate on candidate solutions. Basically, it does not work on that particular domain. Traditional algorithms can only generate one result in the end, whereas genetic algorithm can generate multiple optimal results from different generation. In traditional algorithm only generate one particular solution in the end. But in genetic algorithms, we have multiple solutions because for different generations, because we have number of parents, number of children, number of offsprings, and according to that we calculate fitness functions. If we change one bit of offspring of a child, then the solution is completely different. If we change another bit of that particular child, the solution is different. Because of that, genetic algorithm can produce multiple solutions for a particular generation or a particular offspring. The traditional algorithm is not likely to generate optimal result, whereas genetic algorithms do not guarantee to generate optimal global result, but also there is a great possibility of getting the optimal result for a problem, as it uses the genetic operators such as crossovers or mutations. Traditional algorithm not generate optimal result. Basically, the result given by traditional algorithm is not optimal, and it does not guarantee, and it also doesn't guarantee to generate optimal result. But in genetic algorithm, generally the solution, generally the output is optimal, and it also guarantees to generate optimal result because it uses genetic operators such as crossovers and mutation. In mutation, we have suppose we have a parent and we have their child. We interchange some bits, this is called mutation, or we add some extra bits, this is called mutations. Traditional algorithms are deterministic in nature, whereas genetic algorithms are probabilistic and stochastic in nature. Traditional algorithms determine a probabilistic approach, but genetic algorithm does not find out the probabilistic approach. Because of that, genetic algorithm is much more better to apply, but only on complex algorithm, because if we apply it on simple problems, it will waste our time, it will waste our effort, it will waste our money, everything it will waste it. Because on simple problems we need to calculate it fitness function repeatedly, and we have to perform crossovers and different. For selection, we will select our instances, we will select our offsprings with the help of selection method. If we don't apply it on if we applied it on not complex problems, then it will not work that much good if we apply it on complex problems. Thank you.